Lesson 6 is about graphing trig functions, y equals sine, cosine, and tangent. So the first thing we need to be understanding is that definition of periodic functions. A periodic function is a function whose graph repeats regularly over some time interval in the domain. The length of that repetition is called the period. So, for example, some of you might be musically inclined. There used to be the old style metronomes. I'm definitely not drawing that right, but a metronome is an example of a periodic function where the little arm on the metronome swings back and forth to the time of the music, right? That has a period that it goes back and forth, and repeats the same motion over and over. Your travel on a Ferris wheel ride is an example of a periodic function, that your height will come around and there's a regular rotation interval. And so that is a periodic function. Your height versus time is periodic. Amplitude is defined as the periodic, for a periodic function is defined as half the distance between its max and minimum value of the function. So when we look at these two, take your time to decide what is the period and what is the amplitude. So how long does it get back? How long does it take to get back for period? How long does it take to get back to its same spot? So it starts at 0, and I'm back to the same place right here at 8. So in terms of period, the period of this graph is equal to 8. If I look at the other graph, you need to be careful. When we look at this graph, because it's not sitting symmetrically on the x-axis, you have to look for the 2 points that are the same. And so probably the easiest is to look at these two and say, oh, okay, I can see that. The period for that graph is clearly 6. And lastly, if we again look for the same point, so you pick any corresponding point, but if I pick this this corner right here, then the very same point would be this corner right there. And therefore, that distance is 10. So the period for this graph is clearly 10. Now when we consider amplitude, amplitude is half of the total vertical displacement. So when you're going up and down on a Ferris wheel ride, your amplitude is half of that total distance. So when we look at this, this goes from a low of 10 to a high. The total distance is 20, and we divide that by 2, so that amplitude would be 10. When we look at this, we look for the upper and lower, so that total vertical displacement that this graph goes through in question 2, or B, has a total of 8, but we divide that by 2, so we get 4. And lastly, the total vertical displacement for this graph looks like it has a total of 4, but half of that is obviously 2. So notice we never consider amplitude is not negative or positive. It's never negative. It's just it is just a displacement. In this case, we're going to continue on and use the information we learned on the unit circle to graph y equals sine, cosine, and tangent. So please don't forget the work that you did in the previous lesson on the unit circle, because that's going to be very important to understanding where exactly we graph. This is not something we want to have to go to our calculator on. Clearly, I can type y equals sine on my calculator, but that's not how we want this to go. So without going to your calculator, complete the exact values for each of those. So when you look at this chart, how I'd like you to see it is if I go back to my chart here, if I go back to my previous, you work with the unit circle, I'm going to just pause. Okay, so what you're being asked to do is to give the exact value from 0 all the way to 360 for y equals sine theta, and then plot those values and see what kind of picture it comes up with. Now, you might want to go to your graphing calculator, but I would like you to use what we've learned and keep this pure. So what you need to do is go, well, remember what we learned in the last one? That if you want to know what sine is at 30, well, just find out how high it is at 30. How long is this side? Remember, it's the unit circle. So sine that is normally equal to y over r is really just equal to y because it's unit circle. So if you want to know how high is it, what's the sine at 30 degrees? What's the sine at 60 degrees? What's the sine at 90? What's the sign at 120? What's the sign at 150? What's the sign at 180? And what's the sign value at 210, 240, 270, and all the way around the circle? You already have those. They're on your unit circle. Okay? Fill them in on the chart without having to use your calculator. Okay? So I know what the sign of 0 is. It's the y value. The y value is 0. Y value at 30 was a half. Then it went root 3 over 2. The y value at 90 was 1. The y value at 120 was, it starts to come back down and get shorter, was root 3 over 2. Then it was a half, and then it was back down to 0. And in quadrant 3, the y values get reflected across the x-axis. When you look back to the picture, the y values now get reflected across. There was a half, and as the terminal r comes down, the y value became 0, and now it becomes minus a half, minus root 3 over 2, minus 1, minus root 3 over 2, minus 1 half, and back to 0 again. What are those y values? Hopefully you're starting to see why this is a periodic function and how these values come about. So was 0, it's minus a half, growing minus root 3 over 2, minus 1. Now it's shrinking back towards the x-axis, minus, whoopsie, minus root 3 over 2, minus 1 half, and 0. Now you might wonder, remember when we did the decimals? That's why I asked you to put decimals. So when you go to graph root 3 over 2, remember that root 3 over 2 is really 0.87. So when we graph, what does sine look like? Well, we have to choose a scale. This scale is going 1, 2, 3, 4, 5. So each of those are about 0.2. So when I plot these points, I can clearly see that 0 is 0. At 30 degrees, each of these are 30 degrees. So at 30 degrees, it's a half. And that's right here. Probably not the best scale to use, but clearly a half is right. 1, 2, 3, 4, 5. So 2.5 spaces. So there it's at a half. And then at 60 degrees, it's root 3 over 2. So that's about 0.8 something. At 90, it's 1. And then we come back down. 0.87, 0.5. Back to 0. 0.5. 0.87, 1, minus 1, and you start to see the symmetry, and that's pretty cool. Now notice you could keep this pattern going, because if you go around the circle, we've talked about coterminal, I can keep doing this. The next 30 degrees should be at 0.5, 0.87, 1, 0.87, 0.5, 0. Okay, and then it would keep going down. Once you get the pattern, we go backwards through minus 30 degrees. I can keep this pattern going, minus 30 degrees. And if you go back to unit circle, so you can visualize, we go back to the unit circle and see, if I was to go backwards 30 degrees, negative 30 degrees, clearly I would have minus 0.5, minus at 60 degrees, minus root 3 over 2, minus 1, and that would continue going that way. So when we look back at the picture and we plot these, minus 30 degrees, 0.5, 60 degrees, 0.87, minus 1, 0.87, 0.5, 0, 0.5, 0.87, 1, 0.87, 0.5, and when we graph it, we get a nice smooth curve like this. And there's your periodic function, and we'll answer the questions that have been posed to us there. But the most important part, if a person were just to have to graph its basic function, we've talked about graphs and their critical points. What are the critical, most important points to sine? Starts at 0, goes to 1, back to 0. Every 90 degrees it has something special. So if you can understand how to get those points, you have defined the graph of sine. So now that you have the basic graph for sine, your job is to consider the following questions. You can plot on a grid. You can think about the things that are noted there, but from your own graph, you can clearly tell what each of these are. So take the time to ponder these and then come back and look. The domain for this, x such that x, well, you can have degrees that range from anything. When you look back at your graph, the range is clearly y such that y is greater than or equal to -1, but less than or equal to +1, and y is an element of reals. We really should fix this. We're not talking about x right now. We're actually talking, well, I guess we are in this graph. You could also have that as theta as well. X is an element of reals. The amplitude is 1. The x-intercepts occur at every 180 degrees. So the x-intercepts are, the x-intercepts are 180 degrees times n. Every 180 degrees, an x-intercept occurs, as long as n is an element of integers. The period is 2 pi, or 360 degrees, and the y-intercept is 0. Your job in the next two examples is to complete the assignment and draw the graphs for cosine and sine. Good job.